Okay, chapter 4.1, inverse functions. Okay, first of all, the definition of an inverse function is, okay, if the ordered pair of a function g or the ordered pair of a function f with the order of coordinate reversed, then g is the inverse function of f. What do you mean by this? Okay, the definition is really simple. This one looks hard, but okay, let me draw a graph of a function. Okay, so this is x-axis, y-axis, and let's say here is a graph, something like this. All right, and then this coordinate, the y-intercept is when x equals 0, y equals 1. So this coordinate will be 0 and 1, right? 0, 1. Let's say when x, okay, let me change a little bit. Okay, let me, when x equals 1, let x equals 2. Okay, let's say x equals 2, then this point is 4. This is not drawing in scale, but okay, this point is when x equals 2, y equals 4, right? And then if this is negative 1, x is negative 1, then let's say this is 1/2. So negative 1 and 1/2. All right, then this is the function f. Then the inverse function g is simple. What you do is switch the x coordinate and the y coordinate. Just switch it. So this point, the coordinate of this point will be 1, 0. Instead of 0, 1, it will be 1, 0. Okay, 1, 0. So this point will be coming up here. So 1, 0. And then this point, 2, 4 will be 4, 0. 4, 2. So let's say this is 4 and y equals 2. Let's say this is 2. Okay. All right. And then this point, negative 1 and 1/2. That will be 1/2 and negative 1. So x is 1/2. This 1/2 and negative 1. So this, let's say this is negative 1. Okay. All right. And then connect this point smoothly. Then it looks like this. Okay. Then the graph of inverse function g is this, the red ones. Can you see it? So the inverse function, the coordinates of the inverse function is the coordinates of f with by switching the x and y coordinates. It's a really simple one. So actually the graph of inverse function is this. Okay, let me draw a straight line. This is the graph of y equals x. So this dotted line splits the xy plane in half, right? And then the graph of inverse function is, the point is reflected. The graph of f is reflected across this straight line, y equals x. So this one goes directly, this got to be over here, 90 degrees. This one goes to the other direction, like this. Okay? That is how the graph of inverse function works. So inverse function is really simple. What you do is switch x and y coordinate. That's it. All right. Then the definition of a one-to-one function. Okay, one-to-one function is, okay, when there is one, okay, function. The definition of function is always if there is one input, then that one input will generate only one output. That is a function. So in order for inverse function, so the inverse of that function should to be a function, then also there must be one output for one input. Okay, so it looks like this. Okay, let me draw it again. Okay, let me draw by graphing. Okay, if we have a graph like this, this is y equals x squared, right? Then this is not a one-to-one function because look at this, when x equals 1, y equals 1, right? So we have one point here. When x is negative 1, then y is also 1. So the coordinate of this point is 1 and 1. This coordinate is negative 1 and 1, right? Okay, y equals x squared. This is a function because, with one input, there's one output. So in order to find out if a graph is a function, then we can draw a vertical line, right? We draw a vertical line. So each vertical line contains one intersection, right? And we call it a vertical line test. Then this is a function. Okay, vertical line test. Remember, vertical line test to find out a function, right? So vertical line test means intersect at what? Intersect at only one point, right? Only one point. Then this is a function. Then it's a function, right? Function. So in order for the inverse of a function to be a function, we have to satisfy this function definition. So as I mentioned earlier, the inverse, what's the graph of this inverse function? Switch x and y, right? So 1 and 1. So this 1 and 1 will be 1 and 1, right? This point. And then negative 1 and 1. Switch these two, then 1 and negative 1. 1 and negative 1. Here. So the graph looks like this. Right, the graph looks like this. This is function g. Let's say this is g of x. And this is f of x. All right. So as you see this one, when you draw a vertical line, what happens? We have two outputs, right? Two outputs. One is y value is 1, the other one is negative 1. Two outputs. So this is not a function. Not a function. Right. So the best way of knowing that there is a one-to-one function, if the inverse is a one-to-one function, if the inverse is a function, then we can check one-to-one. So one-to-one means the horizontal line, the vertical line test and the horizontal line test must have one intersection. Okay, then it's a one-to-one function. So let me try it again. Okay, let me explain this one again. For y equals x squared, the vertical line, using the vertical line test, there is only exactly one intersection. So this is a function, but the inverse is not a function because if you draw a horizontal line, test horizontal line test. Okay, horizontal line test. Okay, that means draw a horizontal line, and then if there are more than one intersection, then the inverse is not a function. Okay, the inverse is not a function. All right. So if a graph has one intersection, when you try, using horizontal test and vertical test, if there's only one intersection, then we call it one-to-one function. So if it's a one-to-one function, then the inverse is also a function. All right. Okay, let me check it again. Okay, let me draw a graph. Okay, let me graph this. Something like this. The y equals x squared. This is y equals x squared. Sorry, x cubed. All right, then, the vertical line test. This is a function because the vertical line has only one intersection. Even the horizontal line, look at the horizontal line. Each horizontal line has one intersection, right? So the inverse is a function. So anyway, this is a one-to-one function. So the inverse is also a function. Can you see it? Okay, one-to-one function, make sure horizontal test, vertical line test, both contains only one intersection. All right. Okay, I just rewrote the information. So there are three graphs. The first one is not a one-to-one function because the horizontal line, when you do a horizontal line test, there are two intersections. And the second graph is not a one-to-one function because the vertical line contains two y values. So this is not a function. Okay, and the third one is one-to-one function because horizontal lines and vertical lines contains only one intersection. So this is a one-to-one function, and if a function is a one-to-one function, then there exists a inverse function. The inverse function exists. All right, so the horizontal line test for a one-to-one function is really simple. What you do is draw a horizontal line. Then if the graph intersects, at most once, so only one, right? Only one. You cannot have more than 1 point intersection. So if there is only one intersection, then the graph is actually a one-to-one function graph. Okay, we call it a one-to-one function. All right. Then how about this? Is this for example, is this a one-to-one function? Let's say we have a graph like this. Is this one-to-one? Then that is one-to-one, right? One-to-one, because horizontal line and the vertical lines. So as you draw a horizontal line, there's a one. Each horizontal line has only one intersection, right? How about the vertical line? Each vertical line has only one intersection. So this is one-to-one. One-to-one function. Okay, how about this? Is this one-to-one function? How about this one? Is this one-to-one function? This one, yes, because each horizontal line intersects at only 1 point, right? How about the vertical line? Each vertical line has only one intersection. This is one-to-one function. Okay, how about this? Something like this. How about this one? Is this a one-to-one function? This is not a one-to-one function. Not a one-to-one function. Why? Because look at this. The horizontal line intersects at only one, right? Each horizontal line intersects at 1 point. But look at the the vertical line. Okay, each vertical line contains one intersection. But when you draw a horizontal line, look at this. There are more than one intersection, right? So here's one intersection, another one, another one. All right. So the horizontal line, using the horizontal line test, there are more than one intersection. So this is not a function. Can you see it? But the first two, these two are one-to-one functions. So since these are one-to-one functions, the first two are one-to-one functions, then there exists an inverse function. So the inverse of this function is also a function. Okay, inverse is also a function. But the third one, the inverse is not a function. Okay. Okay, so the conditions for an inverse function. Okay, in order for it to be an inverse function, both horizontal line test and vertical line test must contain what? One intersection, right? So the increasing function means a function f has an inverse function if and only if f is a one-to-one function. Okay, that's what we mentioned earlier. So if it's a one-to-one function, then the function has an inverse function. Then the inverse is also a function. There is a inverse function always, one-to-one function. It's really simple definition. Okay, a property of increasing function and decreasing functions. So if a function is increasing or decreasing function, then what? F has an inverse function. What do you mean by this? So just like a y equals x cubed, like this. This is increasing function, right? So As you go to the right, as x increases, the y increases. Or decreasing function. So, going down. Going down like this. Decreasing function, right? So, increasing function, decreasing functions are one-to-one functions. Okay, this means these are one-to-one functions. Okay, increasing or decreasing functions. This means one-to-one function. Okay, so since these are the one-to-one function, then this function has an inverse function. So the inverse is also a function. All right. Okay. So it's really important. If f is a one-to-one function, then the inverse is also a function. The inverse is also a function. Okay. All right. Okay, when we write an inverse function, we use this notation. So let's say this is a function f of x, right? F of x, let's say 2x. Then the inverse function, the notation is this. So when we write an inverse function, we do this way. Okay, we know that f of x is y, right? Y equals 2x. We can replace it like this. Then what we do is switch x and y. Switch the variable x and y. So this y will be x, and this x will be replaced by y. And then solve for y. Okay, so rewrite it so that then divide each side by 2 so that y equals x over 2, right? Then this x over 2 is the inverse. So you can write it as y inverse. So this little mark, -1. -1 means inverse. Okay, inverse. This is not -1 power. That means inverse. Or you can write it as this, f of x, but put a -1 on the top corner. So same notation. All right. So this is the inverse function. So the graph of 2x and the inverse function is x over 2. All right. So when we graph it, let's graph this one on the same coordinate plane. Okay. So f of x is 2x. So when x equals 0, y equals 0. Let me use blue color. Okay, 0, right? And x equals 1, then y should be 2. X equals -1, then y is -2, right? So that is the function f of x. And then g of x is x over 2. So x over 2 is when x equals 0, then y is 0. And x equals 2, then y equals 1, right? And x equals -2, then y equals -1. Can you see it? So the graph looks like this. So this is the graph g of x, which is x over 2, and f of x, that is 2x. All right. And then, I mentioned earlier, the graph of inverse functions is always symmetrical across the y equals x. So y equals x graph. So reflection, always the reflection of f of x across the y equals x straight line, then that is the graph of inverse function. Okay, so this one goes where? Directly to the other side, like this. This line goes directly to the other side. Make sense? Okay, so I just rephrased this information, how to find the inverse function. So it is really simple. Okay, let me just review it again. First replace this f of x with y, and then interchange the variables x and y, then solve for y, right? Then that expression will be the inverse function. So for the inverse function, we put the negative 1 on the top corner. All right, that's it. Okay, now here's another question. Just an example. Okay, if f is a one-to-one function, so one-to-one means there exists an inverse function. All right, and then f of x. So f of 4 is 5. So x is the input value, right? This is the input value, and then y is the output value. Then what is f inverse f of 5? Inverse function f of 5. All right, then how do I find this one? Okay, inverse function, right? Inverse function means, we replace, interchange the variable x and y. So now 5 is the y value, right? Y value. Then what would be the output? In this case, it should be x, right? X. What's the x value? 4. Can you see it? So the inverse function is really simple. What you do is interchange x and y. That's it. Okay. Then the composition of inverse functions property. Okay, next definition is the composition of inverse functions property. Okay, do you remember the composition function? Okay, anyway, if f is a one-to-one function, then the f inverse. Okay, f inverse is the inverse function of f. If and only if, so there are two conditions. F composition and f circle f inverse is equal to x, or f inverse circle f of x is also x. What do you mean by this? Okay, do you remember the composition function? Okay, what is this one? F circle g of x. What do you mean by this? Okay, this means f of the input of the function is g of x. Remember, like this. Or g circle f means there's a function g, right? And then the input is now f of x. Okay, that is the composition function, right? So in that case, if this f circle g is equal to x, and then g circle f is x, then if this one satisfied, then the function f and g are inverse functions each other. Inverse functions each other. All right. So this definition means this one. So if we rewrite it, the first condition is what? F circle f inverse, right, of x. So if we rewrite it, then f of the input will be f inverse, right? F inverse of x, right? So if this one come up with x, and the second one, f inverse circle f of x. So that there's a function, inverse function f of x, f inverse, right? And that input will be f of x. Then the result is x. So if two results are the same as x, then f and f inverse are the inverse functions each other. But that's the definition. It's a really simple definition. So let's check. Okay, show that f inverse of x equals 3x minus 6. So this is the inverse of f of x. So we want to show these two functions are inverse each other. Then we will check the first condition, which is f circle f inverse of x. Okay, so let's find out whether this becomes x. So this is f of what? F inverse of x, right? So this is the f of x. This is the f of x. So we will replace this x with inverse, right? So 1/3 times x. What is x? x is the f inverse of x, this one. So we're going to replace this x with 3x minus 6. Can you see it? All right, then simplify this. So distribute it. And then minus 1/3 times 6. So that is x minus okay, I forgot writing one more thing, sorry. So there is 2, right? 2. I forgot writing 2, right? 2. Okay, so distribute, then the first one will be x, the second one will be 2, right? This is 2 plus 2. And then negative 2 plus 2 is 0, so it is x. With the result is x. So let's try the second condition, which is f inverse circle f of x. So the function is f inverse, right? And then the input will be f of x. So from the inverse function 3x minus 6, replace this x with what? F of x, which is 1/3 x plus 2. Okay, then use the same thing, distribute, and there will be x, distribute, so this is plus 6 minus 6. So finally it is x. Look at this. So when we check these two composite functions, then they are equal, right? Equal as with x. If it's not other than x, it's not a inverse function. It must have x. The result has to be x. So in this case, these two are the inverse functions. Okay. Therefore, since they are equal with x, f, and these are what? Inverse functions. All right, so next, find the inverse of this function. So write the function, and then we will replace f of x with y, right? And then interchange x and y, interchange. So x equals 3y plus 8. And then we solve for y, right? Solve for y in terms of x. So x minus 8 equals 3y. So x minus 8 over 3 equals y. So y equals what? X minus 8 over 3. And then now replace this y with the inverse notation, y inverse, right? So finally write it as y inverse. So that's the inverse function. Or you can write it f inverse, right? F inverse of x. Like this. That's it. So, or you can rewrite it. You can separate the numerator so that it is something like this. Still okay, right? Alright, so finding the inverse of a function is really simple. Replace f of x with the variable y, and then interchange the variables x and y, and then solve for y. And then finally, rewrite y with the inverse notation, y inverse, or f inverse of x. Okay, now let's find the inverse of this function. So write down f of x equals 2x plus 1, right? And the first step is substitute y for f of x. So we will write y equals 2x plus 1 over x. And then interchange x and y, the variables x and y. So x equals 2y plus 1 over y, right? And then now solve for y. Okay, solve for y. So why don't we do a cross multiply so that we will have xy equals 2x plus 1, right? The cross multiply, where is y 2x? So that is 2y plus 1. Cross multiply, or multiply each side by y. All right, can you see it? Each side by y. And then collect the y terms, because we want to solve for y. So collect all y terms. So xy and then minus 2y equals 1. and then factor out y, right? And then divide each side by x minus 1. All right? So that is the inverse function. So finally, f prime, right? F inverse of x equals 1 over x minus 2. And since the denominator cannot be equal to 0, x cannot be equal to 2, right? So that's it. Simple, very simple. Okay, next, let's find the inverse of this function. This is a quadratic function, right? And then the domain is given. Domain is not all real numbers. Domain x is greater than or equal to negative 2. So actually the graph of this is a quadratic. So it's a parabola, right? Parabola. So the inverse it looks like this. So the inverse is not a function because there are two intercepts, right? So since x is greater than negative 2, it's gotta be half the graph. So only this one. So that the graph will be only this one, right? Only this one. Can you see it? So we will not use the graph on the left side. So that we have only one graph like this. So that the inverse will be the graph of this one. So it will be like this. And this is not the graph. So keep in mind this. So let's find the inverse. So write it, y equals x squared plus 4x plus 3. And then what will be the next? Interchange x and y. Right, so this will be x, then y squared plus, this is 4x. So 4y plus 3. Now we will use this y squared and y term to make a perfect square. Do you remember writing a perfect square? Okay. So let's try that one. So we need half of this, 4 over 2 squared, which is 2 squared, right? 2 squared here. So we added, 2 squared, and then so that we have to subtract 2 squared, right? Plus 3. Do you remember? Okay. Do you remember last time, x squared plus bx, then we need half this one, half of this squared, right? So that this will be x plus b over 2 squared. This is how we make a perfect square. So since we added, 2 squared, we have to subtract 2 squared. All right, then x equals, these three terms will make y plus 2 squared, right? And then minus 4 plus 3. So x equals y plus 2 squared minus 1. And then move this minus 1 to the left. Then x plus 1 equals y plus 2 squared. Okay, so also make a note like this. Let's say x squared equals a. Then what is x? Remove this power 2, right? So it's going to be plus or minus square root of a. Okay, do you remember the rule? Okay, don't forget this rule. Or, okay, let me just show why. Okay, x squared equals a, right? So take a square root each side. Okay, take a square root each side. Then once this is square, then we put absolute value of a, right? Absolute value of x equals square root of a. So what is x? X should be plus positive square root of a, or x equals negative square root of a. Right? So we can rewrite it so that x equals plus or minus square root of a. Can you see it? So this is how we got this. So as a formula, just memorize. So get rid of this power 2, then the right side becomes plus or minus square root. Okay, so take plus or minus square root on the right side. So even this one. So since this is a square, we can rewrite it. So we can remove the square so that the other side will be plus or minus square root of x plus 1, right? So rewrite this. So plus or minus square root of x plus 1. Okay, let's move 2 to the other side like this equals y. So y equals 2 plus or minus square root of x plus 1, right? And then the inverse, so f of x. Finally, the inverse is 2 plus or minus square root of x plus 1. All right. Now, look at this. The domain. Okay, the domain of G is this. Okay, the domain, let's recall this one. The domain of G. Okay, the domain of G will be the range of the inverse. Okay, range of the inverse, always. And the range of G will be the domain of the inverse function. All right, so look at this. The domain is x is greater than or equal to negative 2, right? Greater than negative 2 or equal to. So that's the domain. This is the domain, so the range will be also greater than or equal to negative 2. So the range has to be greater than or, so the range in this case, since the domain is greater than or equal to negative 2, the range has to be greater than or equal to negative 2. Can you see it? So y. So this means, y has to be greater than this one. So this y is the inverse one. Inverse, right? Inverse. So the inverse function has to be greater than or equal to. So it's got to be a 2 plus square root of x plus 1. Okay, let's graph this one. Sorry, it's got to be a minus 2, right? Something was not right. Okay, this is plus 2. So when we move to the other side, it has to be minus. Right? It has to be a minus. Sorry. It's got to be minus, right? Minus, minus. So it makes sense. All right. So we can just remove the minus square root of x plus 1. Because the range has to be greater than or equal to negative 2. So we got to add some positive numbers to this negative 2. So the range is always satisfies greater than or equal to negative 2. So okay, let's graph this one. Okay, as a reference, let's graph this. So g of x is x squared plus 4x plus 3. So let's find the vertex, x coordinate of the vertex. So using the formula, x is negative b over 2a, right? So b is 4, and then replace a with 1. Then we got x coordinate negative 2. Then the y value is just plug in negative 2 for this x value. So that is negative 2 squared plus 4 times negative 2 plus 3. Then 4 minus 8 plus 3. So that is negative 4, so negative 1, right? So the vertex is now, when x is negative 2, y is negative 1. Okay, so once we graph it, so x-axis, y-axis. So when x equals negative 2, y equals negative 1. Here. So that's the vertex. And if x equals 0, then y is 3. Let's say this is 3. Right, so the graph looks like this. Come here, and then the other part like this, right? The other parts. So since the domain is given, domain is greater than, in this case, the domain x is greater than or equal to negative 2. So the graph will be only the solid curve. The solid curve. The dotted curve is not included. Can you see it? Okay. And then the inverse function. What's the inverse function? The inverse function is, let me rewrite it. Square root of x plus 1 and the minus 2, right? Minus 2. So let's rewrite this one. So x plus 1 and the minus 2. So the graph of square root of, this is square root of 2, right? Square root of x. Then this, let's say square root of x plus 1. The the graph of square root of x, right? Then square root of x plus 1 is shift this graph 1 unit to the left. So it's going to be something like this, right? And then minus 2. Minus 2 means bring this one 2 units down, right? 2 units down. Over here, right? So when x equals 0, then y equals negative 1. So the graph looks like this. All right. Okay. So maybe the graph is not accurate. So it looks like this. Can you see it? Okay, so the range has to be greater than the range, which is y, is greater than or equal to negative 2, right? Because the domain becomes the range. All right, so this is the g of x graph, and this is the inverse of g of x graph. So the inverse is when x equals 0, y equals 3, right? This is when x equals 0, y equals 3. So interchange x and y, then there will be 3, 0. Okay, example 6. Okay, there is a formula given, function given, s of x. S of x is this one. And where x is the input, is a wholesale price. So once you get the wholesale price, then you put some margins, whatever, and then it becomes retail selling price. The retail price is S. So make a note that okay, X is the input, right? Input, and S is the output. All right. So letter A, okay, find the retail price. We want to find the output when the wholesale price X is the wholesale price. So this is the X, right? X, the input value. All right, then we can write it like this. S of the input, the wholesale price 672. So that we can replace this X with 672. Then this one comes with 896 plus 100. So the retail price will be $996. Okay, that's the retail price. But this is very standard, normal, right? But look at the next one. Find the inverse, S inverse. And then this time we will find the wholesale price when the retail price is given. So anyway, let's find S inverse and see what happens. Okay, so S of x equals 4/3 x plus 100. So write it down, y. Okay, y equals 4/3x plus 100. And then we do what? Interchange x and y, right? Interchange x and y, and then solve for y. So x minus 100 equals 4/3 y. And then in this case, multiply each side by the reciprocal of 4/3. So multiply each side by 3/4. Okay, 3/4. So the right side equals y, right? And then interchange the side. So then finally, this y will be replaced with the function notation, S inverse, right? So that is the S inverse. So the S inverse is 3/4 times x minus 100. Look at this. Okay, the inverse is always, the domain is range is inverse. Range is the domain, right? So in this case, originally the input is the wholesale price. This is the wholesale, right? Wholesale. So X is the wholesale price, right? And then S is the retail price, right? Retail price. So once we make a inverse, then this X will be the retail price, right? So once we plug in the retail price, then this guy, the output will be the wholesale price. All right. So as you see this, find the wholesale price when the retail price is this one, right? So now plug in this X. So for this value to get the wholesale. Can you see it? Don't get confused. So from here, S inverse of what? 1596. So in this case, this input is the output of the original. So the output is the retail, right? Retail. So the input is the retail, right? This is the retail. So that 3/4 times, what is X? 1596. And then the result will be what? Okay, the result is S inverse, right? The right hand side. That is the sale price, wholesale price. All right, so once we calculate it, the output will be the wholesale price. All right, so that is 3/4 times 1496. Oh, did I write something wrong? Okay. And then once we use a calculator or whatever, it looks like this, $1122. So this is the wholesale price. Okay. That's it. Very simple. All right. Hope you understand how the inverse function relates to the original function, and the graph of inverse is always what? It's a reflection across the y equals x graph, always. So that the inverse graph is an interchange x and y. So interchange all the x and y coordinates of the original graph, so that the graph of the inverse will be, interchange or plotting all the points with interchange x and y coordinates. It's really simple. All right, hope you get this, and then please try more examples.